Number 4, a cylindrical barrel with a diameter of 2 feet across collects rainwater as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height h of the water in the barrel with respect to time is modeled by dH dt equals -1/10 square root h, where h is measured in feet and t is measured in seconds. The volume of the cylinder with radius r and height h is v equals pi r squared h. Part A, find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Indicate units of measure. Okay, this is going to be a related rates problem. They are asking you to find the rate of change of the volume of the water, so that we are looking for dV dt. They tell us that the height is 4. Okay, so we're going to see if we can dig out any more information. They also told us what dH dt is, so I'm going to write that down here as well. All right, and then we also know that the radius is going to be 1 because the diameter was 2. And one special thing about this, notice this 2 is not going to be changing. The radius is always going to be 1. It is a constant. So there are a couple different ways you might have approached this problem. All right, so we're going to start with the formula. V equals pi r squared h. All right, before I take the derivative of this, if you notice that the radius is always 1, you could have just plugged 1 in right now. So your formula would change into V equals pi h. Now I'm going to go ahead and take the derivative. I'll get dV dt equals pi dH dt. And then we know that dH dt is equal to -1/10 square root h. So that is equal to pi times -1/10 square root h. And then they did tell us the height is 4. So then the square root of 4 is 2. 2 times 1/10 is 1/5. So this will be negative pi over 5. You could also have left it as 4/10 or 1/5 or whatever. And the units, we're talking about volume. So this will be feet cubed per, how often? Seconds. Okay, so another way that you could have worked it had you not noticed that r was a constant is you could have had volume equals pi r squared h. F would be pi r squared, G would be h. We'd have to use the product rule. F prime would be 2 pi r dr dt. G prime would be 1 dH dt. So I'd have dV dt is equal to F prime times G, so 2 pi r dr dt times h plus Fg prime pi r squared times 1 dH dt. And then from here, we're going to plug in what we know. The radius is 1. dr dt, since it's not changing, is going to be 0. The height will be 4. Radius is 1, and then dH dt again is -1/10 square root h, and which was 4. Okay, so notice that part drops out. So either way you work it, you end up getting the negative pi over 5 feet cubed per second. Okay, this problem was worth 1 point. If you were able to take the derivative, so you either have this right here or you use the product rule to get it, that would give you a point. And then if you were able to get the right answer, that would give you a second point. Okay, part B, when the height of the water is 3, the rate of change of the height of the water with respect to time, is it increasing or decreasing? So first I'm going to put the height of the water is 3. We want to know, now this was one of those problems, is something increasing or decreasing? What? It says, is the rate of change of the height of the water increasing or decreasing? So it wants to know, is dH dt increasing or decreasing? And if we want to know whether something is increasing or decreasing, we have to take the derivative. So we have to take the derivative of dH dt. So we're going to have to get the second derivative of that. Okay, when I do that, I'm going to rewrite this as -1/10 h to the 1/2. So when I go to take the derivative of that, I'll get -1/20 h to the -1/2 dH dt. And if I rewrite that, I'm going to get -1/20 square root h. The square root h is going to be on the bottom, times dH dt, which is -1/10 square root h. From here, I just noticed you could start plugging stuff in, but my square root h's are actually going to cancel, and I'm going to get positive 1 over 200. So if I want to know whether the dH dt is increasing or decreasing, I got a positive answer. So I would say that the rate of change of height is increasing. And that would be because d squared h dt squared is positive. Okay, that one was worth 3 points. You got 1 point if you took the second derivative. Okay, you got 1 point if you found out the second derivative was equal to 1 over 200, probably deciding that it was a positive answer. And then if you were able to say that it was increasing with justification, you got your 3rd point. So that was worth 3 points there. Okay, part C, at time t equals 0, the height of the water is 5. Use separation of variables to find an expression for height in terms of t. So the biggest thing is the point 0, 5 is on this. And it does say to use separation of variables. Hopefully you remember that is to cross multiply. Okay, so I'm going to have dh dt equals negative 1/10 and the square root of h. If I rewrite it like that, so it's actually a fraction, that's the way to go. I'm going to cross multiply. I'm going to get 10 dh equals negative square root of h dt, negative 1 square root of h dt. I need the h over on the left side, so I'm going to divide by the square root of h. So now I'm going to have 10 over the square root of h dh is equal to negative 1 dt. I'm now ready to take the antiderivative of each side. I'm going to rewrite the left side as 10h to the negative 1/2. So if I take the antiderivative of that, it's going to be 10 times, add 1, add 1 to the power, I'm going to get h to the 1/2 times the reciprocal of the 1/2, which would be 2. So on the left side, this is going to be 20 square root h. And then on the right side, the antiderivative of negative 1 would be negative t plus c. And then from here, you could go ahead and solve it farther, or you could go ahead and find c. I think I'll go a little bit farther. I'm going to get the square root of h is equal to negative 1/20th t plus c. And then at this point in time, I'm going to go ahead and find the what c would be. So they told me that h was 5. So the square root of 5 is equal to negative 1/20th, t is 0, plus c. So that means c is the square root of 5. So I get square root h equals negative 1/20th t plus square root of 5. And now it did say to solve for h, so now I'm going to square both sides. So I'll get h equals the quantity negative 1/20th t plus the square root of 5 all squared. Okay, so that part would have been worth 4 points. I'd get 1 point for separating the variables. I get 1 point for properly taking the antiderivative of both parts. I would have gotten a point for finding, writing plus c and then plugging in my information to find c. So even if you found c incorrectly, as long as you did that step, you would get a point, and then you get 1 point for properly solving for h.